Good morning, gentlemen. Welcome to the Insider videos. Today I want to talk about the cache aside pattern. We start with the problem when retrieving data from the database on every user interactions. You see, we have a user to the left accessing our application service. On every interaction, data is exchanged between our service and the database. The problem here is that for each read operation, the data has to be joined to form the result for our application service, especially when the data is scattered across several tables in a relational database. Second, on write operations, each insert and each update statement has to create an update on the corresponding indexes, usually created on each table, to make queries faster for the database engine. The third thing is that, in a way or another, each database has its data sitting on disk somewhere. So you have a disk I/O operation happening on read and write operations. Even databases that relies heavily on their memory has to fall back to their disk I/O operations when the memory is full. This is not an optimal solution if we want our application to behave in a performant manner. Now, the solution to this problem is to introduce the cache component in addition to our service and our database here. The difference between a cache and a database is that the cache relies solely on its in-memory storage, leading to a better data access throughput. Second, the data structure are simpler than a relational database storage. The nature of the data stored in a cache are of key value pair format. You don't need to issue complex queries and join several data tables in order to form the result. The data is ready for you to collect. So the nature of the data is very important to consider. And whenever you add a data item, you don't have indexes to update as well. Now, for the mechanism of the cache aside pattern, we have a user to the left browsing our data. The first step the application service takes is to check if that data is in the cache. When it is not, a fact known as a cache miss happens. Then our application service has to interact with the database and update the cache with the requested item, then send the response to the browser. In a subsequent request from the same user or another user requesting that same data, The data is found in the cache and returned directly by the application service to the user. A fact known as a cache hit. Now you may ask yourself, what happens when a staff member or an administrator goes into the dashboard application and update that same data item? Let's see. Cache invalidation. The admin here issued a request to update product item X, for instance. Our application service update that data in the database, and only when it receives a successful result, it invalidates that cache item in the cache storage. That's it. It just removes that item key from the cache. In order for the cycle to repeat itself, the user browsing that item again, leading to a cache miss, then fetching that fresh data from our single source of truth, which is a database. Remember, guys, our single source of truth remains a database. In order for the cache aside pattern to apply, then set that cache item to refresh the cache, and then leading to a cache hit for subsequent requests. Now, there are several things to consider before using the cache aside pattern. First, you need to pay attention to the nature of data you are storing in the cache. Beware of storing data that is frequently updated in the database. This will lead to a disaster, guys. Make sure you study each data type you are storing in the cache. For instance, reference type data like a country list or a payment method list, or if you are dealing with an e-commerce site, shipping options list. Data that is frequently accessed and you know that it is not frequently updated. Now, even for some scenarios, because caching this kind of data represent probably 10% of your data types. Now, the value of caching is when it comes to the dynamic data. Now, even for these dynamic data nature, like transaction list, you have to be careful if the data is frequently updated or not. So we have to choose them wisely. The second thing to consider is that even when you apply the cache aside pattern in the best possible way, a batch job or an ETL job or another application you don't have control over, another service like service X hosted in your data center may be dealing or accessing this database without your knowledge. It is out of your control. Never assume that the cache aside pattern is the ultimate solution for keeping your cache up to date. That's why we always have to think about the expiration time of each data cached item. Data for like the reference list here can have a longer expiry time because they are not frequently updated, probably once a year or twice a year. Whereas other data types must have lower expiration time because they are more frequently updated. So always pay attention to these jobs running out of nowhere, coming and accessing your database. This is not ideal, but this is reality, guys. Now, the last thing to think about is that we use the cache aside pattern, guys, is when our caching provider does not provide something we call read through or write through mechanism. Some caching providers give us this possibility. Whenever you try to read the data in the cache, these providers go into the database for us, connect to the database, and update the cache. Or write through, whenever you are writing to the database, it is updating the cache. But even when your caching provider provide these capabilities, on several occasions, I always go to the cache aside pattern because it gives me control of what's happening. Even though we have extra code involved. So these are the things that you need to consider when dealing with caching, guys. Now the last point is a real example related to a retail customer browsing our products. You see a retail customer using the mobile application is fetching product X here through the mobile gateway where we are using the backend for front-end pattern, or the gatekeeper pattern to be more specific. Our gateway fetch the product details from the Docker container. You see if it checks the cache, if it is there, if product X is there, result is normally returned to the mobile application. Now, on the other hand, when a staff member using the admin portal issue an update for that same product X, our Docker staff container receives that update. Then it writes, for instance, a new price, $12, and a new unit in stock updated, becoming 2 instead of probably 3. As you can see in point number 9, after making sure the data is updated in the single source of truth, our database, we are issuing a cache invalidation request to product X, leading to removing that key item from the cache. Now, the next time that same user or another user is browsing that same product, it is checking the product X in the cache. But when it doesn't find it, leading to a cache miss here, the container reads that data and then update the cache, then return the result for subsequent requests. That's a true example of how the cache aside pattern works in action. That's it, guys.